Hello doctor, I am Sivanesh Balachandran, metric number CE200215. So I will be presenting from the first exercise, which is short transmission line. So the question is, 220 kilowatt 3-phase transmission line is 40 km long. The resistance per phase is 0.15 ohm per kilometer and the inductance per phase is 1.3623 millihenry per kilometer. The shunt capacitance is negligible. Use the short line model to find the voltage and power at the sending end and the voltage regulations and efficiency when the line supplying a 3-phase load of. Moving on to the manual calculation, load of the series impedance per phase. So the series impedance per phase is, we can find it by using this formula. So the receiving end voltage per phase is 127 less than 0 degree kilowatt. So the apparent power is, we can find it using this formula. So the current per phase is given by this formula, which is 1000 less than negative 36.387 degree ampere. The sending voltage end voltage is 144.33 less than 4.93 kilowatt. The sending and line to line voltage magnitude is 250 kilowatt. The sending end power is 433 less than 41.8 degree megawatt ampere. The voltage regulation is 13.6%. Moving on to the next part, moving on to the next page, transmission line efficiency is 94.4%. So moving on to the second part of the manual calculation, the current for 381 megawatt ampere is with 0.8 leading power factor is 1000 less than 36.87 degree ampere. The sending end voltage is 121.39 less than 9.29 degree kilowatt. The sending end line to line voltage magnitude is 210.26 kilowatt. The sending end power is 364.18 less than negative 27.58 degree megawatt ampere. So moving on to the voltage regulations, which is negative 4.43%. Transmission line efficiency is 94.4%. So moving on to the next part, which is the coding. So here we have the coding of exercise 1, which is short transmission line. So we obtained the coding from our lab sheet. So the lab sheet had formulas for SR as stated here, and IR, then IS equals to IR, then the formula of VS, then the formula of VSLL and SS formula. So we also have the regulations and EFF formula. So after running the codes for the first part of for 0.8 power factor lagging, we had found the values of VSLL, SS, regulations, EFF and EFF. So the next part, for 0.8 power factor leading. We got the value of VSLL, and this is the value of SS. This is the answer we got for regulations, and this is the final one for EFF. So as we can see that our manual calculations value and the codings are same, so this proves that the work we done is correct. So that's all from me. Thank you.
Hello doctor, my name is Satish son of Anandrao, metric number CE200206 from group 2. I'll explain about the medium transmission line. So the given task is a three-phase overhead line 200 km long, R equals to 0.16 ohm per kilometer, and conductor diameter of 2 cm with spacing 4, 5, 6 meter transposed. Find ABCD constants: sending end voltage, current, power factor, and power when the line is delivering full load of 50 MW at 132 kW. 0.8 PF lagging transmission efficiency, receiving end voltage and regulations. So this is the manual question we did. As we can see here, the L equals to 1.29 mH per kilometer, C equals to 0.009 microfarad per kilometer, R equals to 32 ohm, X equal to 81 ohm, Z equals to 87.1 smaller than 68.4 degrees, Y equals to 0.00056 smaller than 90 degrees, A equals to 0.978 smaller than 0.5, and B equals to 86.4 smaller than 68.6 degrees, and C equals to 0.00056 smaller than 90.2 degrees. For the IR, we got 0.2734 smaller than negative 36.9 degrees. VR equals to 76.21, and VS equals to 95.52 smaller than 7.8, VS equals to 165.44 kV, and IS equals to 0.244 smaller than negative 28.3, and the sending end power factor is 56.49 MV. The efficiency transmission is 88.5%. For the ER with no load equals to 169.16 kV. Percent regulations equals to 28.15%. So this is the manual calculation we did, and we have applied this into the MATLAB with the given code. So it's tally with the answer that we have got in the manual calculation of that. So same, the IR equals to 0.2734, VR equals to 76, Vs equals to 83.0799, Vs1 equals to 143.898738, and Is equals to 0.266979, and the Reg equals to 93.713377G79, and the power equals to 51.278934. We also got the voltage regulation, which is 93.71. The power is 51.278934, and the efficiency is 80.236684%. Uh, the VR no load is 147.629422, and the PCR equals to 11.840472. So it's tally with our manual calculation, and that's all for the exercise 2, doctor. Thank you.
Hi and Assalamualaikum. My name is Muhammad Khair bin Sari. In this video, I'm going to explain for the question and for the exercise 11. So as you can see here, this is the data for the Y bus matrix given, and this is our manual calculation that we have done. So in order to see is it same or not with the simulation. So now I will run the simulation in the MATLAB. So this is the coding that has been given in the lab instruction. So I just run the simulation. Number of buses is 3, impedances is 3. So as you can see here from the table given, for the table given, for the first line, the starting number for starting bus is 1, receiving bus is 2, the impedance of bus 0.1 plus 0.3. And for the line charging admittance is 0.02. And for the second line is starting bus is 2, ending bus or receiving bus is 3, and line impedance of bus is 0.515 plus 0.5, and line charging admittance 0.0125. And for the last line, which is starting bus is 3, ending bus is 1, impedance of bus is 0.2 plus 0.6, and line charging admittance is 0.028. And as you can see here, this is the result for the simulation. So as you can see here, the result is same as our manual calculation that we have done. So I think that's all from us. Thank you.